Okay, guys, the second exercise that we're going to see is an application. The problem says the diameter of a parabolic antenna is of 1.5 meters and has a depth of 25 centimeters. At what height should the receptor be placed? Before I show you how to solve that problem, guys, we have to understand this. Reflection is one of the most important properties of parabolas. Okay, when a wave comes out from the focus, it's going to bounce off on the parabola and it's going to make a parallel reflection, okay? And vice versa. If there's a wave going to the parabola, it's going to reflect and they're all going to end up at the focus, okay? That's why it says here, when a wave emanates from the focus and collides with the parabola, a reflection occurs parallel to the y-axis. So if from the focus I have a wave and it collides with the parabola, it's going to make a reflection that it's parallel to the y-axis. And the same thing the other way. If I have a wave that goes into the parabola and touches the parabola, it's going to collide and it's going to reflect to the focus. Okay? Now, with that in mind, the problem says that the diameter of a parabolic antenna is 1.5 meters and it has a depth of 25 centimeters. At what height should the receptor be placed? So it's asking for the focus. If it asks for the receptor, we need to have the focus. Okay? So, if we take that antenna and we place the parabola on the origin, we can make a parabola that looks like this. That means, guys, that I would be working with a vertical parabola that it's at the origin. So I would be working with x squared, which is equal to 4py. I can take any of the points that they give me, which in this case, I know that I have 2 points, minus 0.75 on this side and 0.75 on this side. How do I know that, guys? Because it says that the diameter, it's 1.5 meters. So if the diameter is 1.5 meters, and I know that a parabola, it's symmetrical, then I know that from here to here, it has to be 0.75, and from here to here, it has to be 0.75. Now, notice that this 0.25, guys, it's not the focus, okay? That's just the depth of the parabola, all right? So I have 2 points, negative 0.75, comma 0.25, and positive 0.75, comma 0.25, okay? You can substitute any of those 2 points in this equation. I substituted negative 0.75 and 0.25, and you get the value of P. You know that P is a distance that you should always have between the vertex and the focus. So this means that the coordinates of the focus would be 0,0.5626 meters. Therefore, what that means is that the receptor should be placed at 56.26 meters centimeters from the vertex. Okay? That way, there will be a reception. Otherwise, it will never have a reception. Okay? So that would be an example of an application.